Hello everyone, welcome to this episode where we will explore systems thinking, a powerful approach to understanding and addressing complex problems. We will use VEGERA project as an example for understanding complex social ecological systems and to illustrate how systemic interconnections work. So, what is systems thinking? Systems thinking is both a mindset and a method for making sense of complex systems. These systems can be ecological, they can be social, technological, logistical, or a combination of all these. At VEGERA, our focus is on social ecological systems. In essence, systems thinking helps us in understanding how different elements in a system are interconnected. Secondly, it helps us to identify feedback loops that drive or balance the system. And third, systems thinking provides us with ideas and helps us to create meaningful change, a sustainability transformation. So first, let us zoom out and take a global perspective. Let's start at the global level. Picture the global ecosystem, the foundation for all life on Earth. This ecosystem which provides us with critical services like water, materials, energy, etc. Our social systems, the nations, the different kinds of organizations, even families as a subset, are deeply embedded into this global ecosystem. And nested in the social systems, we find the economic systems. In turn, these operate within the social systems. Trade relationships, price signals, the production of networks, these all are parts of this nested structure. And this nestedness, where systems exist within systems, is a key concept in systems thinking. So, importantly, both on global and local level, we depend very much on the functionality of ecosystems so that they are intact. And for example, climate systems, which we have explored in other VEGERA video episodes, these can be seen as prime examples for complex interconnected systems. So let's take climate systems as an example to explore something we call feedback loops. Namely, feedback loops are central to the understanding of systems, and there are two main types. The first one are reinforcing feedback loops, and the second, balancing feedback loops. Let's start with the first one, reinforcing feedback loops. These amplify changes within a system. For example, as global temperature rises, goes up, permafrost in Siberia starts to melt, releasing methane into the atmosphere. Methane, as a potent greenhouse gas, accelerates climate change, and thus this creates a self-reinforcing feedback loop. But when we look at the climate system, we also find balancing feedback loops. These stabilize systems. For example, increased CO2 level in the atmosphere can boost plant growth, like the growth of trees, which absorb more CO2 from the atmosphere. While this effect has limits, when the CO2 concentration grows too much, it can be harmful for plants, but so far it has mostly acted as a balancing mechanism when we look at the climate system. And these kind of balancing and reinforcing feedback loops we can find in many systems. So, and understanding these kind of loops also helps us in recognizing tipping cascades, tipping points, critical thresholds where small changes can lead to a significant impact on larger systems. And for more on this, please check out our previous episode on climate, but also simulation tools like those provided by Climate Interactive, which are available on the internet and which are based on robust systems models. Actually, the similar kinds of models that we are talking here, but with equations and based on more recent climate research. So let's then zoom into our VEGERA projects and see how systems thinking works in the context of the project which addresses climate change. It tries to integrate agroforestry systems, the fostering, having more of these agroforestry systems, and efficient housing using agroforestry timber as a material. And let's try to visualize this system. The iconography looks as follows. If there is a blue arrow between two variables, it means that an increase in A causes an increase in B, or a reduction of E causes a reduction of B, so the direction is to the same direction. A red arrow between two variables means that an increase in A leads to a decrease in B or vice versa. So this is just a simple iconography that is used, for example, in Vensim type of modeling, Vensim being a computer tool for visualizing complex dynamic systems. So when we look at our project and the project idea, what are the interconnections? Planting trees, shelter belts on agricultural areas increases the size of shelter belts. So larger shelter belts then reduce wind speeds in agricultural areas, which will lower the water consumption of the agricultural agroecological system. Reduced water consumption again eases the pressure on water resources, improving the sustainability of the agroecological system. So we can find some feedback loops also in this system. Planting more trees increases the availability of sustainable timber, and this timber supports and provides material for energy efficient construction, which can boost the demand for agroforestry products. So the higher demand motivates more tree planting, creating a positive feedback loop. When the prices of timber are stable, the farmers are more interested in planting actually trees and taking care of these shelter belts. Now when we look at the variables in this very simple model, we find two types of variables. The size of the shelter belts is called a stock variable, which can be measured in hectares or meters or kilometers. The other type of variable we find is planting trees, which is called a flow variable. And this can be measured by the number of trees which are planted annually. And distinguishing between the stock and flow variables can help us to model more effectively and make models which are more useful for our purposes. This kind of a model can also help in finding leverage points. And this is a key goal of systems thinking and modeling complex systems. To identify leverage points, so places where interventions can lead to significant positive changes. For example, leverage points could be policies that incentive tree planting, or educational programs to promote agroforestry, or third, investments in energy efficient housing technologies. So by using models and visualizations, qualitative modeling of this kind, such as causal loop diagrams, we can identify these leverage points and design interventions. So the application of systems thinking is very versatile and can be applied in many fields. For example, in education, teaching students to think critically about complex systems. It can support policymaking, helping policymakers design more effective interventions or interventions which are most likely to be implemented by the different actors. And third, we can use this in research. We can use causal loop diagrams in interviews and in generative dialogues with different stakeholders. If you want to dive deeper into the topic of systems thinking, check out resources like those provided by System Innovation YouTube channel. And this will cover different topics, including feedback loops, stocks and flow variables, time delays in complex systems, dynamics of systems, etc. So thank you for joining us on this journey into systems thinking, a brief introduction. We hope this episode has inspired you to explore the interconnectedness of systems, and we hope that you have fun in learning more about systems thinking and applying this and the approach to your own challenges. Thank you very much for your attention.